So in this video, I wanted to show you how titrations are used in a practical way. They are typically used to find the concentration of an unknown solution. So if we know the concentration of one solution, we can figure out the concentration of the other using the titration method. And the way we typically do this is we have a known solution in a burette. Let's say this is NaOH in here. And let's say that molarity of NaOH is 0.5 molar. And we have our solution down here of, let's say we're using an acid, HCl, 15.0 milliliters of it. And we do not know the concentration of the HCl. But because we know stoichiometry that a 1-to-1 ratio these react with, and we can figure out the end point where they both perfectly neutralize each other, we can figure out how many moles of acid are in that beaker. So if we think about this in terms of our NaOH and we're doing the titration, remember last semester we can put something in here. We can put an indicator in the solution that will change colors when the pH goes from acidic to just slightly basic. That's the end point of the reaction. So the end point means turns pink for the indicator that we used last semester. That was, what was that? Phenolphthalein, it was called. So it turns pink when all of the acid react with base. So we add NaOH until this turns slightly pink. What that actually is a slightly basic solution, but it's so close to the equivalence point, the end point of the titration, that we use that point to say all of the acid is now reacted. So let's say we added exactly 20.70 milliliters of NaOH. And then our solution now, see if I can get a little highlighter. There we go. That works for now. So we got HCl in there still. 20.7 milliliters of NaOH. So how do we use this information? Well, I'm going to circle the important information that we need. The molarity of NaOH, how much we needed, and then the milliliters of HCl. Let's think about this reaction. So the reaction really is NaOH plus HCl yields H2O plus NaCl. These react in a 1-to-1 ratio. So we know it took 20.70 milliliters of 0.5 molar NaOH to react with 15 milliliters of question mark molar HCl. So now we really just have to think these moles on the left equals these moles on the right. So we're really just missing one variable here, and there's a useful equation. It kind of looks like the dilution equation that we used. When you dilute a solution, the molarity times the volume on the left will always equal the moles times volume on the right. It's very similar to that, because if we think about this, the moles times the molarity times volume will equal moles, and that has to equal the same thing on the right, because they react in a 1-to-1 ratio. So we don't even have to convert this to liters or anything like that. We just have to plug these values in. We know that it took 20.70 milliliters times 0.5 moles per liter. That would actually give us millimoles, but it doesn't matter because it's the same units on the left and the right. So the molarity of our HCl times the original volume should equal the same number. So the molarity of the HCl, we solve for that. Divide both sides by 15 milliliters. It should be 0.690 molar of our HCl. So when you see these dilution problems, they're actually pretty simple. And you can think of them as, a lot of times they're just a word problem. So if it says a titration is performed where 20.7 milliliters of NaOH was required to reach the end point, and it was titrated against 15 milliliters of HCl of an unknown concentration, what is the concentration of HCl? Really, you just need to remember this 1-to-1 ratio. So volume times molarity should be equivalent to volume times molarity for the HCl. Now, I just wanted to point out, what if you had a reaction that looks like this instead? So let's say we use NaOH in our burette, and instead of HCl, we have H2SO4 in here. Remember, you always have to look at the reaction. H2SO4 is a diprotic acid. So it's actually going to react with 2 moles of NaOH per 1 mole of acid. And you get your salt, Na2SO4 plus H2O. Same type of neutralization reaction. But importantly, this 2 here. So let's say the molarity of the NaOH in our titration was 0.250. Volume needed to reach endpoint as in the volume needed to neutralize or react 100% with all the H2SO4 was 32.20 milliliters. And the original volume of the acid over here, we had 26.60 milliliters. Let's say this is our titration problem. Remember that equation that I gave you, the molarity of A times molarity of A, whoops, sorry. So I'm going to put this in, molarity of the NaOH times the volume needed of the NaOH has to be equivalent to the moles, sorry, not the moles, the molarity of the acid times the volume of the acid. We can still use this equation. We just need to remember, though, that this does not react in a 1-to-1 ratio anymore. So the only thing we really have to do is think, okay, molarity times volume, that's the same, because it took this molarity times this much volume, but it's no longer equivalent to just 1 mole of the acid. So if we think about the stoichiometry, I'm actually going to calculate that out really quick. 32 point, what did I say? 2? This is equivalent to 8.05 millimoles. I multiplied molarity times milliliters. So millimoles of NaOH. And if we actually think about the stoichiometry, it's a 1-to-2 ratio. So I'm converting from moles of NaOH to moles of H2SO4 consumed. We need to put 2 moles oh, I'm sorry, that's the wrong ratio. I need a 2. Let's go back. And let me fix this. Getting rid of NaOH on the bottom. 2 moles. In this case, millimoles. NaOH to 1 mole H2SO4. So you'll notice that that ratio is a 1 to 2, so I actually should divide that by 2. So this actually is equivalent to 4.025 millimoles is equivalent to the molarity of the acid times the volume of the acid, which was 26.6. So be careful when you're using this little shortcut for the titration problems, because you need to make sure you recognize the stoichiometry of your acid and your base. So this was milliliters. So if we solve for this, let's divide this side by 26.60 milliliters divided by 26.6. We get 0.151 molar H2SO4. Feel free to look up more of these problems. If you just search for titration of strong acid with unknown concentration, for example, something like that, you'll find a bunch of these on the internet. And these examples were from the internet themselves. All right, I'll see you guys for the next problem lecture.